Hi everyone, welcome to Numeriq Learning. Welcome to the Do Math With Me series day 52. Today we'll be solving problems from trigonometry, both introduction to trigonometry and applications. So let's get started. The very first question is you have to prove the given identity, right? Prove that tan cube theta by 1 plus tan square theta plus cot cube theta divided by 1 plus cos square theta equal to secant theta multiplied by cosecant theta minus 2 sine into cos. Okay, so let us convert, let's take our LHS and convert everything into sine and cos. Okay, so I am going to abbreviate, okay, sine as S, cos as C. Okay, so that it's easier for me to write it. So let me take LHS. Tan cube, tan is nothing but I can write tan as sine by cos, right? So tan cube theta is nothing but sine cube by cos cube theta whole divided by 1 plus sine square by cos square theta, okay, plus cot cube theta is nothing but cos cube by sine cube whole divided by 1 plus cos square by sine square. Now let me take the LCM in the denominator. So you have got sine cube by cos cube whole divided by cos square plus sine square divided by cos square in the when you are taking the LCM, right? Cos square, here you will have cos square plus sine square. Again plus you have got, let me erase this part now that you have understood. So cos cube divided by sine cube whole divided by, you are taking the LCM. LCM is sine square plus cos square. Now you have to combine these fractions. Numerator of the above fraction with the denominator of the below fraction. Denominator of the above fraction with the numerator of the below fraction. So this is how you will combine and write the terms. Okay, so let's combine them. So it is sine cube multiplied by cos square whole divided by cos cube multiplied by sine square plus cos square, which is 1. Okay, plus cos cube multiplied by sine square whole divided by sine cube multiplied by 1. Okay, now what can we cancel? Cos square and cos square, sine square with, so what remains now? What we have got now is sine cube by cos plus cos cube by sine is what remains. Now let's take the LCM. Cos into sine is the LCM. So here, so cos multiplied by what will give you cos into sine? It is sine. So this sine multiplied by sine cube is sine to the power 4 plus cos to the power 4. Okay, now you should know an identity. So here this is of the form a square plus b square. Okay, so you should know that, see, a plus b or a square plus b square, the whole square is nothing but it's of the form a square plus b, a plus b the whole square. So it is a to the power 4 plus b to the power 4, which is, see, a plus b the whole square, right? In place of a I have written a square, in place of b I have written b square. So what will be a square? A square the whole square is a to the power 4 plus b square whole to the power square is b to the power 4 plus 2ab. So plus 2a square b square is an identity. Now you need to know this. So what is a to the power 4 plus b to the power 4? It is equal to a square plus b square the whole square minus 2a square b square. So this is something which you should remember. Okay, this identity will frequently be used in 10th. So now in place of a square we have got sine square. See, just compare it here, look here. So this is sine to the a to the power 4, sine to the power 4. In place of b you have got cos. So now let us use this identity and expand it. So what will you get? Sine square plus cos square the whole square. I am just writing what I have written here. Okay, minus 2 sine square cos square. Okay, so what is this? A whole divided by, there is a denominator also. This is the numerator, whole divided by cos into sine. So what is sine square plus cos square? It is equal to 1. 1 square is just 1, right? So 1 minus, what did you have? 2 sine square cos square divided by cos into sine. Split the denominator among the numerator terms. So what do you get? 1 by cos into sine minus 2 sine square cos square divided by cos into sine. Now you can easily cancel it. One cos will get cancelled, one sine will get cancelled. Again here 1 by cos sine is nothing but 1 by cos into 1 by sine. What is 1 by cos? Secant theta, right? Into 1 by sine is cosecant theta. Minus, there is a 2 here, 2 sine theta into cos theta. Okay, I believe this is our RHS. Okay, secant theta into cosecant theta minus 2 sine into cos is equal to RHS. Hence proved. So just write like this and you will get full marks. You will absolutely, whoever is correcting your paper, okay, the evaluator will not have any reason to reduce your marks anywhere. Also make sure that you write these identities also which you are applying it in trigonometry. Those algebraic identities which you are applying it in our problem, right, in order to prove the identity. Always make sure you write it. So this is how we do proving the identity kind of questions. Let's do another question. Okay, you have to prove that. So I hope you understood this. Please make sure you do it. Pause the video and do it. Yeah, the next question. Prove that tan square A divided by tan square A minus 1 plus cosecant square A divided by secant square A minus cosecant square equal to 1 by. So again, here also we will be doing the same thing. We will take our LHS, convert everything into sine and cos. Tan square is nothing but sine square by cos square divided by sine square by cos square minus 1. There is a plus here. Cosecant square is nothing but 1 by sine square divided by 1 by cos square minus 1 by sine square. Take the LCM in the denominator. So sine square by cos square is the numerator divided by sine square minus cos square divided. I'm just doing it directly. Just take the LCM plus 1 by sine square whole divided by denominator term. You'll have sine square cos square. So you have sine square minus cos square. Again, let us group. I always have the practice of drawing these lines in order to combine them so that it's easier. So now what do you do? So sine square into cos square divided by cos square multiplied by sine square minus cos square is the first term. Second one is sine square cos square. So you're just combining them. 1 multiplied by sine square cos square will be numerator. Denominator will be sine square multiplied by sine square minus cos square. Okay, sine square into sine minus cos square. Sine square minus cos square. So here, right? Now take 1 by, you can take out common or you can cancel this. See, cos square will get cancelled. Sine square will get cancelled, right? So you can take 1 by sine square minus cos square, you can take common out. What will remain inside? Sine square plus cos square, which is equal to 1. This is equal to 1, right? So what remains is only 1 divided by sine square minus cos square. What is the RHS? You need 1 by 1 minus 2 cos square. You don't need a sine square. So what can we do? We can replace sine square by 1 minus cos square minus cos square. So this is nothing but 1 by 1 minus cos square is minus 2 cos square equal to RHS. Okay. That's all. So maybe at the end when I'm writing it, I will make sure I write it entirely. This is cos square A. Yeah. Cos square A. Yeah, 1 by 1 by is equal to RHS. Hence proved. Hope you understand. It's very, very easy, right? Because you need to prove something in terms of cos. So convert all tan, cosecant, secant into sine and cos. Right? Let's do another question. Yeah. If tan A equal to n tan B and sin A equal to m sin B, prove that cos square A equal to m square minus 1 by n square minus 1. So here, okay, we have to find cos square A in terms of m and n, right? This means that cos of which angle is something which we need, it's only angle A. So we have to eliminate angle B. This is what we understand. Okay, let me repeat again. Whatever you are given in A in terms of B, angle A, sine of angle A in terms of B. But what you need to prove is cos square A in terms of m and n, which means what? You don't need angle B. So we have to eliminate angle B from the given relation. So let's do it carefully. First one, tan A equal to n tan B, right? So what is tan B equal to? Tan B is equal to, you can write tan A by n. Okay. What is cot of B then? It is 1 by tan B, right? You just have to take the reciprocal. So n by tan A. Okay. If tan B is 1 by A, then what is cot B? It is just A. It's just a reciprocal. Okay. Similarly, what else is given here? Sin A equal to m sin B. Let's do the same thing here. So therefore, sin B equal to sin A divided by m. What is the reciprocal of sin? Cosecant. So cosecant B is equal to m by sin A. Why? Because 1 by sin is cosecant, 1 by tan, isn't it? So 1 by tan B. So when it goes to the numerator, it will become n by tan A. Okay. Now what is the relationship between, what identity relates cosecant and cot? We already should be knowing that. We know that cosecant square B, okay, here theta is B, minus cot square B is equal to 1. This is something which we should be knowing because we would like to eliminate it. So in place of B, what will I put? Cosecant B, I'll write m square, m by sin A, right? M square by sin square A minus, in place of cot B, I'll write n square divided by tan square A equal to 1, right? Now what can I do? I'll convert this tan into sin and cos. So m square divided by sin square, okay, minus n square divided by sin square by cos square. Okay, so now this is equal to m square divided by sin square. Is it sin square A? Yeah. Okay, so let me write it fully. Sin and cos. Okay. Sin square A minus n square cos square A divided by sin square A. I hope it's clear now. Is it clear? So, right now, what can I do? Take sin square common. So, you have sin square A is common as the LCM. So, in numerator, you will have m square minus n square cos square A. Okay. Now, this is equal to, what is it equal to? Based on the identity, look here. You are using an identity and it's equal to 1. So, this is equal to 1. Cross multiply. So, what will you get? M square minus n square cos square A equal to sin square A. Okay. We don't need sin square. We need cos square A. So, we'll convert it. So, m square minus n square cos square A equal to 1 minus cos square A. Let us rearrange the terms. M square minus 1, take it to one side, and you can take n square cos square A minus, you already have a cos square A, to the RHS. Take cos square common, cos square A common. So what will you have? N square minus 1. Here you have got m square minus 1. Therefore, what do you get? Cos square A equal to m square minus 1 divided by n square minus 1. Okay, you just have to rearrange, take out common, and you will be getting only cos square A as the trigonometric function here. So trigonometric, the function will be cos square A equal to, everything else will be in terms of m and n. Okay, so just be very careful. In between, you should know where from this one is coming. This is from this identity that we have taken. Okay, I hope it's clear. Now, let's do one more question. Okay, this one. In the figure, okay, in the figure, you are given OACB. Okay, so listen carefully. OACB, so in an entire circle, so if you have an entire circle, when you're dividing it equally into 4 quadrants, right? So this is 1/4 of a circle. So OACB is a quadrant of a circle with center O. The radius is 3.5 centimeters. So this radius is 3.5 centimeters. Okay. If OD is 2 centimeter, okay, find the area of the quadrant OACB, right? So what are you given? You are given the radius, right? So radius is given as 3.5 centimeter. This is equal to 35 by 10, right? So 5 sevens are 35, 5 twos are 10. So I can write it as 7 by 2 centimeters. Okay. Now the first question, what is the area of the quadrant OACB? It is just 1/4 of the area of the circle. So 1 by 4 into pi r square. So what is it? 1 by 4, pi is nothing but 22 by 7 into r is nothing but 7 by 2 into 7 by 2. Write it twice. 7 by 2 the whole square. Okay. So here 7 and 7 will get cancelled. 2 into 11. That's all. So this is nothing but 77. 11 into 7, 77 by 8 centimeters square. This is the area of the quadrant. Okay. Next, you have to calculate the area of the shaded region. So the area of the quadrant minus area of this particular triangle. If you calculate the area of a triangle and if you subtract it from the quadrant, what will you get? You will get the shaded area. So let us calculate the area of the shaded area. In order to calculate the area of the shaded area, you need to find the area of triangle OBD. Okay, so let us calculate what is the area of, in order to know area of the shaded region will be equal to the area of the quadrant OACB minus area of the triangle. What is the triangle? OBD. OBD. So let us calculate the area of the triangle OBD. Okay, area of the right triangle OBD. Half into base into height. So what is the base in this particular triangle? Base is OB. Height is OD, right? Half into, you can write down half base into height, half into OB into OD. What is OB here? OB is the radius. Radius in place of 3.5, I'm going to write it as 7 by 2 for, in order to make it easier for me. Okay, multiplied by 2. OD is 2. So again, you can cancel 2 and 2. What is left is only 7 by 2. 7 by 2. This is the area. That's why the unit is centimeter square. So now that you know the area of the triangle, okay, you know the area of the triangle, you know the area of the entire quadrant. That's why when you subtract quadrant minus this, minus the area of the triangle, what you will get is area of shaded region. So therefore, you can write area of shaded region is equal to area of the quadrant. What is the area of the quadrant? 77 by 8 minus area of the triangle, which is 7 by 2. Take the LCM 8. So you have 77 minus 2, 4 side, 4 into 7, 28. What is 77 minus 28? So you have got 9, 6 minus 2, 4, 49 by 8. You can leave it as it is, centimeter square. So this is what is the area of the shaded region. Okay. I hope you understood. It's very, very easy. Just that you have to take care and do it. Be very careful when you are calculating these values. Okay, taking the LCM, when you're subtracting, all these are some minute things which you have to take care of. And during the exams, you have to really write it very, very fast. So practice more questions so that your speed increases, your accuracy increases, you are able to spot out mistakes, you get time to even revise and recheck once before submitting your answer sheet. So please practice every day. I hope you liked the video. See you all in another Do Math With Me series. Till then, take care. Happy learning.